Hello students, welcome to VB Academy. So in this channel you will get the content related to mechanical engineering diploma based government jobs. Say you are preparing for competitive exams based on diploma mechanical engineering as well as other branches. Okay, low electrical, electronics, CSC and other departments like civil. So I will provide the content for mechanical student first and all other non-core parts. Say for government jobs things you will need core part. Core part means your mechanical subject as well as the non-core part like quantitative aptitude, reasoning, general awareness and general English, and these things you will need. So I am going to provide all these things free of cost at our VB Academy YouTube channel. Okay, so this is the initial day of VB Academy channel. I am going to launch today now with the engineering material subject. So for mechanical students I am going to start with the engineering materials. All other subjects I will complete later. Okay, so engineering materials. What? Engineering materials. Engineering materials. In every competitive exam, this engineering materials carries nearly on an average 5 to 8 or 10 marks in single day exam based competitive exams. Means engineering materials. What? Engineering materials. Engineering materials. So what is mean by engineering materials? The materials which we are using in daily life are the engineering materials. Clear? So engineering materials means what? The materials in daily life we are using. Basically these engineering materials classified into two categories. Okay, what? Engineering materials are classified into two categories. What we basically called it as EM. What? EM. What? EM. These engineering materials are basically classified into two types. First is metals and non-metals. What? Metals and non-metals. What? Metals and non-metals. Metals and non-metals. Metals and the non-metals. Okay, metals like iron, copper, aluminium and extra things. While coming to the non-metals, glass, rubber, plastic, these are the non-metals. These are the metals. So basically we will mainly focus on these metals. These metals are again classified into two types, Nana, here. These metals are classified into two types again, like ferrous materials and non-ferrous materials. What? Ferrous. Ferrous and non-ferrous. Ferrous and non-ferrous. Ferrous means in ferrous materials the iron contains as a main constituent. Okay, in ferrous materials the iron will be main constituent. In the non-ferrous materials the main constituent will be other than iron. Main constituent will be other than iron. So example of these ferrous materials is steel, iron, cast iron. These are the ferrous materials which contains iron as a main constituent. Okay, if you check this, cast iron contains nearly 95% of the iron. Steel nearly 90 to 93, means based on the alloys. Okay, coming to the non-ferrous materials like copper, pure elements or their alloys maybe. Okay, copper is a pure element. Okay, then aluminium, pure element, and their alloys, say copper, aluminium, then brass. This is the alloy of copper and zinc. Bronze, alloy of copper and tin. These are what, Nana? Non-ferrous materials. Means in these non-ferrous material, iron won't be the main constituent. Clear? So this is the ferrous material. this is a non-ferrous material. See, what is the engineering materials? Engineering materials are those materials which we are using in daily life. Why we have to know about these engineering materials? Means as a design engineers and the students, okay, so what you have to do, based on applicability, you have to change the properties of this material. Say for making of ornaments means a jewelry, you require more ductile material. Whenever you go through these materials, you will know the property, then only you can apply it properly in daily life. Clear? Say you have to bind the wires, means make the wires, thin wires. For that type of material, it requires more ductility. Clear? That is the property of material. Okay, so first chapter we are going to discuss in its engineering materials is mechanical properties of the material. So engineering materials has different types of properties, man. Okay, different types of properties. So I will list the properties here first. Electrical properties. Second one is thermal properties. Third one is chemical properties. Fourth one is what, Nana? Electrical, thermal, chemical and physical and mechanical. What, Nana? Mechanical. We won't bother about this electrical, thermal and chemical and physical. What is mean by electrical? How good a material is conductor, how good a material is insulator. So based on electrical pass, means electric current passage, we will define whether it is a good conductor or whether it is a good insulator. Based on that, we will classify the materials. That is the electrical properties. While coming to the thermal properties, how the material react with the metal, or sorry, with the temperature, is we will get the thermal properties. Coming to the chemical properties, how it is bonded, how the chemical bonding inside the material. Based on that, we will categorize the chemical properties of the material. Then coming to the physical properties, how the appearance of that property. Enormous means physical appearance, how it is look like, what is the size, that is comes under the physical properties. But the mechanical properties, we mainly focus on this mechanical properties. These mechanical properties of the material are obtained by one test, that is called tensile test. What is tensile test? In this tensile test, we make use of a UTM machine. UTM means universal testing machine, on which machine we can conduct both the test, compression test and the tensile test. So in this, what we have, I will let you know. See here. What we have here, Nana? Here we have the specimen. Specimen means the workpiece which is under test. We call it as specimen. This is the specimen. Tensile specimen. Tensile test specimen. We will apply tensile load on this. What, Nana? We will apply tensile load on this. What is meant by tensile load? Tensile load means the load applied in the push nature. In the pull nature. Pull means it has to elongate the body. Means this specimen is get elongated, and all other properties like ductility, elasticity, plasticity, malleability, brittleness, toughness, resilience, creep, all other properties we will not. Means creep and fatigue, we will go with other test, and hardness test also, other test will be there. But major mechanical properties are obtained by this tensile test only. Clear? So whenever the load is applied on this body, whenever the load means any external agency which causing body to move or to develop internal stresses, or body to stop or body to accelerate it, that is the force. Force means force does four things on the body, man. Whenever the force acts on the body, it does four things on the body. First is whether the body If it is in motion, it accelerates it. If it is in motion, it stops it, or it starts the motion, or it develops the stresses in the body. That is the external agency on the body. Whenever it acts on the body, it produces these four things. That is the force. That is what force means. If this force is in the pulling nature, that is the tensile. If it is in the pushing nature, then that is the compressive force. This is the tensile force. So based on this, we will get major properties. More properties we will get here. So I will let you know one by one. Okay. See here. First one is strength. What is meant by strength, Nana? What is meant by strength? Strength. First one is what, Nana? Strength. See here. First one is strength. First one is strength. Strength means the ability of the material to withstand the externally applied forces without any failure. That is the strength of the material. What is? That is the strength of the material. Are you getting by? So whenever the external force is acted upon the body, the ability of that particular material with which the body is made. Are you getting by? Say here, this is the body, ma. This is the body. What? This is the body. Here you can check here. This is the body. This is the body. Whenever I am applying the tensile force on this body, this body will resist the force till one point. Okay. Say if it is made with, this body is made with pure copper or copper plus zinc, that is brass. Say this body is made with the brass. Whenever I apply the tensile force, the body will withstand up to one limit. Clear? Up to one limit. After that, it will get failure. Get means get broken. Okay. At that point, what is this strength of that body? Gives the strength. Gives the strength of that particular material. Clear? So what is meant by strength? Take the note, ma. What is meant by strength? The ability of the material. The ability of the material, not the body, ma. The ability of the material. Ability of the material. The ability of the material to resist. Ability of the body to resist the externally applied forces. Externally applied forces. Externally applied forces till yielding or breaking. Or fracture or failure, what it is? Fracture. That is the strength, Nana. This is the strength. This is the strength. Hope you got this strength. What is meant by strength? I am repeating again. The ability of the material. What, Nana? The ability of the material to resist externally applied forces till its yielding or fracture. Getting my point? Till its yielding or fracture. That is known as strength of that body. Strength of that body. Then coming to the plasticity. This is the plasticity. This is the plasticity. Say, take one wire, Nana. Take one wire. GI wire means galvanized wire, iron wire. Hammer it on this. Hammer it on the wire. What will happen? It will get bulge. It will get bulge means it will flatten. It will flatten. It will get flattened. Okay. So you can't regain its what? You can't regain it shape to round. Clear? After hitting with the hammer, what happened? It get flattened. So you can't regain it. You can't regain it. If you hammer slowly, it won't flatten directly. It will slowly get flattened. Clear? So what is meant by plasticity here means in this context, what is meant by plasticity? Whenever the load is applied on the body and body deforms permanently, then that is known as the ability of the material to deform permanently under the applied forces is known as plasticity. whatever it may be. Maybe it may be compressive force or it may be tensile force, but the ability of the material to deform permanently under the applied forces is known as plasticity. Clear? You are getting right. So whenever I am applying the hammering means I am applying the external force on the wire and it gets flattened and it won't retain its circularity. Are you getting? So due to that, what happened here? What happened? Due to applying external force, that is hammering, the roundness of wire is gone and flattened. Means the deformation is permanently retained. Clear? That is the plasticity. So write it down now, Nana. What is the ability of the material? The ability of the material. The ability of the material. The ability of the material to deform permanently under external applied force. Under externally applied forces. What, Nana? Externally applied forces. Under externally applied forces. You are getting it? This is the plasticity. Then coming to the quite opposite property of this. Quite opposite property of this is brittleness. Brittleness means it will also go permanent deformation, means directly fracture. So as you are hitting on the wire with the hammer, okay, now what you have to do, hit with the hammer on the glass. What happened? It won't get flattened here, it will directly break. You are getting it? So what is the difference you are getting here, right? So if you hit with the hammer on the glass, what happens? It will get directly break. Means little bit permanent deformation will be there. Means with our naked eyes we can't see that deformation. In the brittleness case, what happened here? Due to this property of the material, it get broken easily. Without any permanent deformation. This is a quite opposite property of plasticity. Okay, due to this property of the material, the material get fractured without any permanent deformation. Means this plasticity, due to this plasticity of the property of the material will fracture after permanent deformation. Even though if you are applying more forces, in plasticity as well, material get fractured. If you go beyond the strength of that particular material, it will get fractured. But before going to the fracture, the permanent deformation will be there in that particular body or the material. But in the brittleness, due to this property of the material, it will get directly fractured. This is the very dangerous property of the material, ma'am. Okay, so due to this property, we can't see with our naked eyes what is the fracture is going on. It will take suddenly, without any permanent deformation. Due to this property of the material, what, Nana? Due to this brittleness of the material, it get directly fractured without any permanent deformation. The example of this brittle materials is cast iron. Clear? So I will write it now here. Due to this property of material, it will fracture without noticeable deformation. Without noticeable deformation. You are getting right here. What is meant by brittleness here? So due to this property of the material get failured, but we can't know. Means with our naked eyes we can't see it. Means the noticeable permanent deformation won't be there. It get directly failure. This is the deformation. Okay, this is the brittleness. So now coming to the next property, that is the elasticity. elasticity. Okay, in elasticity means this property, how the properties means whenever the force is applied on the body, whenever the, say, take the example of what we called